All right, let's continue on. We just got done doing 3.1 in part A of this video sequence for today. Right now, we're going to do 3.2, which was the promised dispersion. Or another word for it is deviation. But before I do that, I want you guys to do something for me. I have two data sets, set A and set B. And your job is to calculate the mean. So let me write in the data. Set A has 10, 30, 50, 70, 90. Set B is 48, 49, 50, 51, 52. This looks like a set of instructions. It's not a set of instructions, it's a in-class assignment. Conveniently constructed by your student.
Calculate the mean of them together or
Separate, do them, the mean of each group separately. I mean, you could do them together, but that's not going to help what I'm trying to present, the idea I'm trying to present here. Anyone still working on it? You should have gotten 50 for both of them.
30?
No. Not 30. Are you fucking with me?
I swear you had them all up and you divided by the amount of them, right?
If you add these up and divide by the number of entries, which is 5, the 10 plus the 90 is 100, the 30 plus the 70 is another 100, 250 divided by 5 should be 50. I don't know how you got 30. Like, only one score is below 30. Oh, I bet you did it in your phone. No? Maybe you should have.
Yeah.
I don't know how you got 38. Yeah, it should be 50 for both. But if we look at the data, clearly that mean doesn't really mean a whole lot, does it? It's also the median on both, if you look at it. The median's 50 for both also. So clearly, like, the center of the graph doesn't really tell us, or center of the data doesn't tell us everything. So this leads to the idea of dispersion. We can see from above, set A's data is spread out or dispersed more? You all have seen dispersion in real life, even if you don't think of the word dispersion associated with it. And I know a lot of people don't smoke anymore, but if you've ever been, you had to have seen at least a smokestack on a building, at least from a distance, you can see the smoke where it comes out of the building. But as it goes up, it looks like the smoke just fucking disappears. Like it goes poof, it goes away. It's not. It's spreading out so thin, it's dispersing throughout the air that you don't see it anymore because it's not like, there's not enough percentage content for it. That's what dispersion is. And so where it applies to here is like, how far away from the center is our data? That's what like the idea of dispersion is. One way they do this, which is the weakest way to do this, is called the range. The range is one way, and it's the maximum value minus the minimum value. For set A, this is 90 minus 10, which is 80. And for set B, this is 52 minus 48, which is 4. The problem with the range is that this is not resistant. If we're talking about income, Elon Musk fucks this up. Every once in a while, I'll find someone, I'll get a review from someone or be told by someone, so unprofessional for you to cuss. I'm like, I had a lot of teachers in my life that had their stick up their ass and they never cussed and they never talked to their students like they were fucking peers. They always talked to them like the fucking grand overlord of the room, and it's my way or the highway. And their classes fucking sucked. It didn't matter if I liked the topic, their class sucked. My job is to teach you, and if you don't want to pay attention because I suck, I've already lost you, no matter how well I know the material. If you don't want to listen to me, I'm a shitty teacher. By cussing, I bypass all that and it allows me to be myself. It's fucking great. I could never get away with this at a high school. I would be fired probably before the end of the day. First day.
That's what I was thinking.
Probably.
We had a professor at Exeter High School who was a CS professor who came and taught and was very
It was very,
ludicrous with his language.
yeah.
You're more than me?
Honestly, probably the same one.
About the same level, but he used his in a defensive manner.
Yeah.
Ah,
He was mean. He was,
He was an
he was,
asshole.
yeah.
different.
that's completely different.
It was, but he was like,
Among
if
yours.
your parents want to complain, this is a college class, not through the school, so suck it.
Yeah.
Like, that was basically his attitude.
I mean, he was funny, but he was kind of a dick sometimes.
Oh, and if you didn't take him for the second semester, he'd go back and change your grades. Like,
That's not legal.
shit like that.
He can't do that at the college.
He did to me, and then I went to the counselor, and she made him go back and rechange it.
Like how much after the semester was
Yeah,
over?
he dropped me from a B to a D.
I just had
Going into
I'm gonna pause this for a second, because this is actually important, but I wanna know more. I don't wanna have to go edit it. Because I thought the story was coming. All right. So range isn't resistant to outliers, and so we don't like it. And the one we like is standard deviation. And a lot of times you'll just hear people say, just deviation. When you hear deviation statistics, they're talking about standard deviation. It's got some fun formulas. We talked about the symbols already. The population's standard deviation is xi, the square root of the sum of xi minus mu squared over n. That's for populations. And for samples, it's similar. There's a summation sign. It's xi minus, instead of doing mu, we do x bar, but they're both the mean. And for the sample one, we do n minus 1. This is this is like an adjusted standard deviation. N minus 1 is called the degrees of freedom. And I think the easiest way to talk about degrees of freedom is just do a quick example. Since I'm a lazy fuck, I'm not gonna get up. I'm gonna just have you guys pick. Here, if you could have one of these pins, which pin would you pick?
Black.
Theodore picked black. John Luke, GL, what you got for me?
Green.
Mateo, what color do you want?
Red.
Did Mateo have a choice? Was he free to choose what he wanted? No. So degrees of freedom is always one less than the total. There were 4 pins, but only 3 of you really had a selection. That's the idea of degrees of freedom. When you see these in StatCrunch, and we'll be doing these all, like all the shit we talked about today, I'll show how to do in StatCrunch before we're done. This one shows up when you see it, it's at the bottom of the list. It says unadjusted standard deviation. And we rarely, if ever, use it. This one goes by standard or STD dev. The development of a STD. Completely different than standard deviation.
Just tuned into the last of that. What?
Theodore's over here fucking ignoring me. That's what I just heard.
I'm not ignoring.
You just said, I just tuned in. I heard it.
It's not on purpose.
I'm just too boring.
No, it's just ADD.
That works. All right. So what do we need here? Xi are all the individual data values. We already talked about mu or x bar. These are both means. And we've talked about n and big N, and these are the group sizes. Well, if we have all the data values and we have the n, this one can this one can be found with the other two, with the rest of the info. And really, so can n. If you want to take the time, you can find what n is by adding up how many entries there are. So what we really need, this is the most important. We can't do standard deviation without the data values. In StatCrunch, we can see the mean, we can see standard deviation, all under stats, summary stats, columns. And you're gonna do this right now. And we're gonna find the standard deviation of the two data sets we did earlier that both had the same mean and the median, the 50. Let's go figure out the standard deviation there. Just making sure everyone's ready. Everyone good? Okay. I'm gonna come over here, I'm gonna go into StatCrunch. And I'm gonna load up a data set. Because I can always put my own column in. What did I do? 48, 49, 50? And 52. Okay. So if I want to see the summary stats, you go stats, summary stats, columns. My data is in columns 15 and 16, so I will select them. There's a big bucket list of shit we could use here. There's a lot of good stuff. And most of the things you do will show N already. But notice it's already highlighted. This is the list in gray is like the entire list. The list in white is what's automatically selected every time. It's usually way more than you need. It's got the mean selected, it's got the variance, which the variance is the standard deviation squared. I think I said that earlier. Standard error, we will be looking and using median range, min max, Q1 and Q3 tomorrow when we do 3.5. The min, the max, the median, and Q1 and Q3 are called the 5-number summary. We'll be doing that tomorrow. The range we just talked about a little bit ago, it's like subtracting the high minus low. You really don't need that if you can see the data. Like most of the time you can do it by hand, but I'll just do the full list, let you see what it shows. It shows us that the mean and the median were both 50. We did that correctly. The standard deviation for the first group with the 10 through the 90 was 31.6 if I go to 1 decimal place, and the 48 through 52 was 1.6. So you can see the higher the standard deviation, the more spread out that data is from that center median. The one that had the 10 and the 90s got large numbers. The one that doesn't has small numbers. Anything else fun here? We did the range earlier. We can see that by looking at the data. We'll do that on tomorrow. All right, back to drawing. What else do we need in here? Oh, so like, let's talk about standard deviation a little bit more. I kind of said this verbally, but if you want something in your notes, the greater the standard deviation, the greater the dispersion or spread. This is where we get a graph. It's a cool graph. It's one you should memorize. So I'm going to draw as well as I can, and then I'm going to show you a picture of it, show you where to find the picture. But it's pretty much everywhere. This is the empirical rule. Let me try to draw a fucking standard deviation graph here. Bell curve graph here. Now recall X bar and mu are mean. S and sigma are standard deviation, whether it's for sample or population. I tend to use the Greek letters here, even though when we're actually doing the assignments, we're usually using the regular letters. Mu on the bell graph, the mean is always in the middle. That should be the middle. It looks like I missed by a little bit. Looks like my hill's a little lopsided. Pretend it was a good picture. I guess I can do like this, trim it a little bit. There we go. Trim it a little bit. I need some white out. If we, and remember, this is like a value. So like for our, I'm gonna do the 40, both have shitty standard deviations. I'm gonna use the IQ test example. For the IQ test, the mean is 100. The standard deviation is 15 for the population. I will give you the website where you can go do this. This is like the official, like the first IQ test. Some people don't like it because it's really like how quick are you with quantitative numbers and like how quickly can you read and interpret. And like it doesn't show like emotional intelligence. It doesn't show like physical intelligence, which to me, kind of want to call bullshit on that one. But whatever. I've seen websites that have like 8 different kinds of intelligences. This one's just your standard IQ test. 100 is your middle ground. So if you have an IQ of 100, you're average. The IQ test, the population's IQ follows this bell curve. So for the population, this is 100. If I go 1 standard deviation this way, by adding 1 standard deviation to that value, and I go 1 standard deviation to the left by subtracting 1, this covers, each of these is 34% of the population. So within one deviation, 68%. Now, if I were to do this here, I need to add sigma here. This is 100 plus 15 is 115. This value is 100 minus 15, which is 85. There are problems in the homework which will give you like the mean and the standard deviation. And it will say like what scores or what values encompass 68%. This is what they're wanting you to do. They're wanting you to figure out what these two values are. For IQ, it's 85 and 115. It's going to be different for each kind of question it is. If we go out another standard deviation, which is about the same distance, we keep just adding a little bit more. This is now I've added 2 of them, or I've subtracted 2 of them. Each of these adds another 13.5%. Which means if I do this range right here, between plus or minus 2 deviations, if you add that up, it's 95% of the data is there. 95% of all responses will be in that range. Here, I'm basically adding another 15, or 100 plus 2 times 15 is 130, and this one's 70. I'm subtracting another 15. If we go out 3 deviations, I did this all right today. This is not a bad graph. Sometimes it's atrocious. Other than that little scribble block thing, it's a decent representation. In this region, we have 2.35%. I'll do this one in different colors since it's outside, it's a little harder to see. If I go from plus or minus 3 deviations, between plus or minus 3 deviations, if you add that up, it is 99.7%. And beyond that is 0.15% on both sides. It's very little. Three deviations would be 145 and 55. So for someone that has a score above 145 IQ, they are in the top 0.15% of the most intelligent people in the world. I am not one of them. I'm above the 50% mark.
What's considered genius?
I want to say it's 132, but it might be 142. I think it ends in 2. I think when you get to 130, like, let's take a look at this. This is a good question. Someone that has 130 score, let me like move this so it's a little bit like this. So someone that has an IQ of 130 is going up to the mu plus 2 sigma. Look at what's higher. We have 2.35% and 0.15%. This is 2.5%. Someone with a score of 130 is smarter than 97.5% of the people they meet. That's a fucking lonely life. You don't meet people that are smarter than you very often. Believe it or not, 115 is really good. An IQ of 115? If I could fucking write a 1. That's the mu plus sigma. It's got 13.5 plus 2.35 plus 0.15 higher than it. This is 16%, which means they are smarter than 84% of the people they meet. In like a room of 50 people, 8 of them are smarter than you, on average. You're generally not in a room of 50 people. Even in a classroom, a full classroom, generally you're pushing 30, maybe 40, depending on the classroom size. But in 30, now you're looking at maybe 2 or 3 of them are smarter than you, on average. That's not very many. You're like one of those top score students. You're getting an A. You're going to be one of those A students. So like having a score of 115 doesn't sound very big when you hear like genius is 142, but it's still smarter than 84% of the people they meet. That's pretty good. If you do if you want to take this test and see where you score, they have like a fast test and then like a slow test. There's like one you can do, like it's like 25 minutes and it rushes you. It's at Stanford Binet Test.com. That's the official one. It's humiliating to take. It don't matter how fucking smart you are. They literally have to put enough questions on there to keep the smartest person on the fucking planet busy the whole time. You know those motherfuckers are solving that shit right away. Like you look at it and you're like, I don't even know where to start. And they're like on 3 problems later already. By the time you said, I don't even know where to start, they're 3 problems later. So like by the time you do like 10 problems, they've done like fucking 80. There's a lot of problems. And I think it tells you I forget if it tells you how many there is, but I got the impression, I remember when I took it, that like I didn't get shit done. I think I had like, I forget what it was. I'm gonna have to go take it again. Forget what my score was. It wasn't fucking 140 like I wanted it to be. I always like to think, hey, you studied astrophysics, you're pretty fucking smart. Like, no, not relatively. Like I'm like, I think I'm above 115. I think I'm below 130 last time when I did it. I don't know, it's been a while. I did a lot of drugs as a teenager, probably fucking lowered my score. I didn't take the test before I was a teenager. Don't do drugs, teenagers. Be good. Stay away from ibuprofen. That's what I meant. All right, so this is the empirical rule. This bad boy right here. They will ask you to do a lot of shit. They'll be like, what percentage of the score? They'll give you a mean, and they will give you a standard deviation. and they will ask you what percentage of the scores is between this value and this value. And I guarantee those two values that they give you, if you calculate out what the numbers are on the bottom, like I did here for the IQ test, they are two of these numbers. And then once you know which two they are, you just start adding up the percentages between them. They're more than likely going to do the 95% one. They'll probably do one with the 68% one, but then they like to throw it off and like do like one down and then two up and shit like that. So like being able, it's worth drawing out this picture a few times until you memorize it. And there is a pattern. Notice that as I go away from the center, the numbers are the same. 34, 34, 13.5, 13.5, 2.35, 2.35. They are memorizable values. The top ones that are the most important to know, when you're not doing questions like what are the between these two values, the big takeaway ones are plus or minus one deviation captures 68%. Plus or minus two deviations is 95%. And plus or minus three deviations is 99.7%. It's very important that you know this and remember this. This is the empirical rule. This is more like a rule of thumb. When we show how to calculate all this stuff normally, if you do plus or minus two deviations, I want to say it's really like 95.45%. That's fucking pain in the ass to memorize. I don't know why, when you already got to memorize like 2.25 and shit like that. But it's harder, it's more to memorize than just going 95%. We tend to say that the outliers are outside the plus or minus 2 sigma. So it means they are less than -2 or greater than +2 sigma away from the mean. If you guys look up that file on Canvas with the lecture notes, what page is this? Page 25 has a nice pretty picture. So this is page, I guess I'll have to put the screen back up, but like it's in the lecture notes, page 25. It says page 25 in the lower, like I'm looking right here. Where's my mouse? There it is. Page 25 down here. I don't know what page it says. It says 34 here. Or 34, depending on where you look. So you want, or you can Google standard deviation or empirical rule. Google empirical rule. And as long as you find the one that actually shows the 95%, some people like to put the 95.45, but that's not the empirical rule. Empirical one's got the simpler numbers, 68, 95, 99.7. That's section 3.2. Let's take a look at 3.4. Everyone ready? Three point four is on measures of position. Now, I looked this shit up, I don't know if it's changed. Average male height. And average female height are mu is 70 inches. And for women, mu is 65 inches. And if we want the standard deviation for each, men are 4 inches and women are 3.5 inches. Scotland, how tall are you? 5 foot? Excellent. You're gonna make a great candidate for this. Scotland is 5 feet tall. If we convert that to inches, she's 60 inches tall, which is less than the 65 inches. Myself, David, I stand at a proud 5 foot 5.5 because I care about that half inch. When you're short, it fucking matters. Tall people don't give a shit about the half inch. Short people do. If I convert that to a score, that is 65.5 inches, which is less than the average male height. Okay, so we are both shorter than the average height of our respective genders. I assume, I'm making an assumption, you identify as a female. Okay. It's not always safe to assume nowadays. So like, comparing our two heights isn't good, because I'm taller than her, but like, am I taller than more percentage of men than she is percentage of women? Like on a relative scale of our respective genders, like where do I stand? Am I at like the fucking 20% mark, the 40% mark? I'm below half, because I'm not at average. And where is she? If we could figure out like a respective scale for each of our genders and find like a percentage mark for us, then we would know like which one is taller relative to our specific genders. Thankfully, we have a means for that in statistics. This, how do we compare? This is like comparing apples and oranges. Comparing our two heights isn't fair, because I have a genetic makeup that makes my gender generally taller. It's not true in all scenarios. There are fucking Amazonian, well, I would say Amazonian women, but they're not fucking Amazon. They might be. Some of them have got to be for the Amazon. So like you got your WNBA women, and then you've got your fucking horse jockeys that are like 4'6" men riding around on horses. Like they're taller, they don't even come up to the horse's belly. Like, I don't know how they get up there. They need like a fucking lift. It's a ladder.
They get launched. They're like literally someone stands there and they're right there and they get launched and thrown over the horse. It's like...
Okay, so like we want to like, so we don't want to compare any two people without like doing like a respective thing. So how do we do this in statistics? It's called the Z-score. And I'll show you the formula for it, but it stems from any one person's score, regular value, not z-score. Regular value x is x plus z x equals mu plus z sigma. So the z-score, on the z-score rating system, it represents how many standard deviations you are away from the mean. How dispersed or how spread you are from the center of your respective group. Now, doing a little bit of algebra. Might have been a while for a lot of you. I'm going to walk you through real quick. If I want to find out what z is, first off, I would subtract mu from both sides. And I get x minus mu equals z sigma. And then I could divide both sides by sigma. And I will get z, which I will put on the next page. We can calculate the z-score by doing x minus mu over sigma, which means to calculate it, we need to know x is the person's actual, in this case, height, or the person's value. Mu is the mean for that population. And sigma still is standard deviation for population. So I'm going to rewrite what the mins and females are. Min had a mu of 70, sigma of 4, and the women, I was about to say female, but men and female sounds fucking like, I don't know what fucking talking about. Mu is 65, and sigma is 3.5. And let's find the z-score for me in Scotland, and then we'll know. Whoever's got the higher z-score is taller respective to their gender. So for me, I was at 65.5. That was my x. And her x was 60. Z equals, I got the formula up there. Let me move it that way. Now that I got what I needed off of it. X, which is my score, minus mu, which is that height. I'm not gonna put the inches there because it's cluttering shit up. And standard deviation score. And her z-score is 60 minus 65 over 3.5. My z-score is negative 1.125. Her z-score is negative 1.4 3. I went 3 places on mine, we'll do 3 places on ours. Now I can put us on the same bell curve. I couldn't put us on the same bell curve before because we had different means and different standard deviations. And so like they didn't match up. Now I can. On the z-score graph, these are exactly integer numbers. The average is 0. The mean for z is 0. And the standard deviation for z is 1. That's pretty fucking handy. Which means we both fall in this range. I'm right about there, and Scotland's just a little bit to the left. So we're both, I don't even want to look at the fucking percentages. Maybe I do, just never done that. This is fucking gonna be disappointing. Like up to 1 standard deviation, this is the bottom 16%. So more than 84% of our respective genders are taller than us. That fucking hurts. I've never thought of it like that. That really fucking sucks. God damn it, you guys just ruined my fucking day. I really never thought of it, like, thought this class many times. I've never really thought about like what percent. All of my friends that I play Dungeons and Dragons with are fucking taller than me. One, not a lot. He's like 5'7" maybe. Enough that when we're standing up, he just looks down a little bit. But like when we're playing Dungeons and Dragons, we're all sitting down. And that fucking long leg shit goes away. They're under the fucking table. We're all about the same height. So like I spend most of my time with them around a table. It's like, not bad. Then we fucking go out to like Chipotle once. We're standing in line. And they're all fucking looking down at me. I'm like, fuck you guys. My brother's terror. My brother is like 5'11", I think, 5'10". Enough that like I come up to here, like my eyes are right here for him. So like when we're standing next to each other, I have to do this. He's my baby brother. He's like less than a year younger than me. And he still does it to this fucking day. If we stand this close and he tips his head down and it occurs to him that he's fucking looking down on me, he just starts smirking. And I know when he's thinking about it because it's just out of fucking nowhere. We can be talking about anything and all of a sudden, he just starts smirking. I'm like, fuck you, dude. I don't give a shit if you're taller than me. I'm smarter than you. Fuck off.
My 6th grade sister is eye to eye to me.
Is what?
Is eye to eye to me.
Really?
Yeah, she's about 2 feet taller than me. He uses a tear to me.
My little brother's 2 years younger than me, and I'm 5'4", 5'5", and he's 5'10", 5'11".
He's the youngest and he's the tallest.
Fucking
Like,
hate that shit.
overpassed both of our parents and all of our uncles. Like, he's just
Right?
outrageously tall for me.
This is where, when he's pissing you off, you say, that's because you're not really a fucking Costa. You were fucking adopted, you took the wrong one home at the fucking hospital.
The thing is it's.
Daddy was-
They say it's adopted because we're Portuguese and my brothers are both really dark, with dark hair, and they get really tan.
Okay?
And I look
You're the adopted.
like the adopted one, so.
Doesn't matter. Still, if you're all the same height and he's the fucking outlier, well, you got your own outlier with skin tone, but like, still. He's the baby one, he's the baby brother, so you gotta fuck with him a little bit. He don't know better.
And his car can't make up the driveway, so.
Alright, back on task. That's how you calculate z-scores. And then you can compare them. And so like, that's what we use for bell curves. For dispersion and measures of position on bell curves, we have our mu/x bar, we have our sigma/s, and we use the empirical rule. Usually when the like especially later on, because you haven't done anything but the empirical rule, but then later on chapters where you like knew how to calculate the actual like percentage, not just like say, oh, it's 2 deviations, it's 95%. When you know how to do it, if they want you to use the empirical rule, they'll tell you. I hope they're doing it in this lower chapter. They'll tell you when they want you to use the empirical rule, because it's more meant for like a quick rule of thumb, and I don't need to go do no fucking math for it. If you know the mean, the standard deviation, it's basically addition and subtraction. And if you know the rule of the empirical rule, you could tell pretty quickly with just a little adding and subtracting where someone's like z-score is, or where, like if they're an outlier, where they're at on it. If you wanted the actual value, this is where you're busting out some software because you don't want to do it by hand. That means go and get the laptop or your desktop. It's a pain in the ass. What do we do for skewed graphs? For skewed graphs, we like the median and the IQR. IQR stands for interquartile range. IQR, when you calculate it, is Q3 minus Q1. You guys remember seeing that on StatCrunch, the Q3 and Q1? It also has IQR on there. Maybe I should tell you what quartiles are.
It's like box plots, right? So
Yeah, this is where you're gonna have the box plots. We're gonna do that tomorrow. Box plots, part of the 5-number summary. But like quartiles are like percentiles. Now, if I was exactly 1 deviation below the average for my, I was at negative 1.1. If I was negative 1.0, I would have been the 16th percentile. Percentiles are, when you have a percentile for a score, the percentile shows the percentage of people that are below it. Shows the percent, not people, I'm going to say, it shows the percentage of scores below it. I don't know if they still do this. I think they still do. SATs. They still do high school SATs?
Yeah.
This is like if you want to go to university straight off gate, you don't need an SAT for COS. The fucking thing people don't know is that community college teachers tend to do a better fucking job than university teachers. Teaching. Our job is to teach. That's all we do. We should be fucking good at it. It's the only thing we do. Fortunately, that's not universal. At a 4-year university, their job is to do research. That's their job. Teaching is like something they have to do. It's like, we we have to do some service for the public, so we're gonna teach too. So when you get to like a 4-year university, you got great researchers. You may not have a great teacher. I've had some shitty fucking teachers that were super fucking smart. They could do some great research, could teach for a damn. They didn't have the people skills. You know what I mean? Where the fuck was I? Oh, SATs. That's how it got me there. So like SATs, you use them at the 4-year, but SATs do the same thing. If you hit the 98th percentile on the SAT, you were smarter or got scored higher on that version of the test than 98% of the people that took it. This is how, if you want to go to graduate school, if you go to a 4-year university and you want to go to graduate school, you're going to take the GRE, which I think is graduate requirement exam. I don't know what the R is. I think it's requirement. It tests you on a range of shit. Generally, if you're in like a very fine-tuned subject, like math, they have their own like GRE, but it does the percentage the same way. They give the same test at the same time throughout the entire fucking country. Word for word, number for number, problem for problem, so that no one has an unfair advantage over someone else. Like there's no numbers that are like, these numbers are easier than that person's, so they did that. So like, you can actually, if you don't need to like do apples and oranges shit. Different tests have different numbers, so they don't compare different tests together. SATs, I think, are the same way, GREs is that way. I got fucking blown away on mine. I was like 67 percentile or something. Except that it might even been lower than that. I gotta go look. I think I still have the email from fucking, what was that, over 10 years ago. Yeah, it was just fucking stomp your shit down. You ain't fucking no shit, you don't know math. Go on. I still got into a lot of places because it's like, if you do the bell curve, it's a pretty good score. No, not really. Not really, but enough. I got into several schools. The only one I didn't get into was University of Washington. They didn't want to let me in as a PhD. Which is good because I didn't want to move to Washington. All right, so quartiles are the same idea, but they go off quarters. So like Q0 would be our minimum score. It's like the 0%. Nobody's shorter than you. Q1 is 25%. 25% of the people got a lower score. Q2 we don't use, but it's effectively the median. I mean, we use it for our box plot and our 5-number summary that we're going to do tomorrow, but this is 50%. Q3, 3/4 is 75 cents, 75%. And Q4 is our max. You have the highest score, 100% of the scores are your score or lower. So the reason why they like the IQR for the skewed graphs, for measuring like the idea of dispersion, is like, let's see, the median is more towards the center than the mean. It's usually to the shorter side. This might be Q1, this might be Q3, and you're looking at this middle 50% for the IQR. IQR is looking at that region right there. So what does that do? If we have outliers, outliers are over here. So it fucking shuts out outliers. which means IQR is a resistant score. It's a resistant thing. They don't affect it a lot. Where do we define an outlier for this stuff? Let me show you. So for this skewed stuff, this is how we do outliers. We find something called the lower and upper fence. And it's a fairly easy calculation. The lower fence, I'm going to call it LF. We take Q1, whatever that score is, not the percentage, we know what the percentage is. We take Q1 and we subtract 1.5 times the IQR value. And the upper fence, we have Q3 and we add 1.5 times the IQR value. You can actually find Q1 and Q3 by hand, but it requires you to sort them. And the way you find Q1 and Q3 by hand is first you find the median, and then now you know where like the middle of the data is. And then like for the Q1, you ignore the top half of the data, and you just find the median again of the smaller side. And to find Q3, you find the median of the upper side. Put it in software, it finds it really quickly for you. But it's just really the sorted values and really just going up until you've got 25% of the scores are below. These are the same value, so once you've computed them once, it goes really quick. And this is part of the 5-number summary, so I'm going to do more with lower fences and upper fences tomorrow. And you'll see where the outlier idea lies a little bit better, but outliers are below the lower fence or above the upper fence. And if I didn't mention it earlier, if you want to know where the outliers are and the other on the bell curve, outliers for bell curves, are outside, I think I did actually, outside 2 deviations. If you're looking at the z-score, if you've already, like, don't convert to a z-score if you don't need a z-score, but like if you have a z-score, alternatively, it's below -2 or your z-score is greater than 2. We call those the outliers. A lot of times we don't have any. We can be done, that's 3.1, 3.2, 3.4, we're gonna do 3.5 tomorrow. If you guys would like, I can show you 3.3, which there's no homework, not being graded on it, but it's how weighted GPA is calculated. This might be of interest to you. If it's not of interest to you, you can get the fuck out or start working on your homework. If it is of interest to you, I'm gonna go over it. How about that? John Luke is like, I don't fucking give a shit. I'd rather just get the homework done. That's fine. So weighted average.
Wait, this won't be on the test, right?
Correct. If it was, I would tell you, fuck, pay attention. Weighted average, this is in like the hidden 3.3. You do not have homework on it. It's not on the test. But it's handy to know. They got a pretty little formula for it. Well, I don't know how pretty it is. We're doing an average, but they put a W there because it's weighted. Which means when we say weighted, it means some scores matter more than others. Some scores matter more than others. And we use that for weighted average. The formula for it is, we do that whole, we have the summation, we've got that XI thing, but each of these is multiplied by their weights. And then rather than dividing by n, we are dividing by the sum of the weights. When you're doing this for GPA, the X bar for GPA, this is the sum of the units you've taken, or the unit per class, times the grade in that class, divided by the total number of units you've taken. So, like, let's just do an example. Let's say in a normal, like, I can't really use summer classes because you're probably only taking one. Well, yeah, one. Stats class, the number of units for a stats class is 4 units. English, anyone know how many units in English classes? Is it 4 or 3?
It's on the call.
English 1.
It's 4.
I think it's 4 too. I'm pretty sure there's a library or study skills one. And it's only 1 unit. Now let's say this is your first semester and you're like, I'm gonna knock out English 1 and I'm gonna knock out stats. And I think they make students, they're supposed to make students take this the first semester. This is library 1. Let's say you want to get above 12 units. Our units frequently have like 3 units, right? And let's say your grade in these classes, when you get it, let's look at the outcome from doing it 2 different ways. Let's say you focus heavily on stats and English. These are fucking important to you. You didn't really give a shit about this, so you got like a C, and you got a C in art. You didn't care. This is some fucking shit that doesn't happen. What I'm about to say next, like art people, stats people can care, math and English people can care about art. Art people can care about stats and English. But let's just say you're one of those who's like, I don't fucking like math or anything. I don't like writing papers. I don't like doing math. I fucking don't care about this. So let's do like, you get a C in those. And you're like, oh, study skills, that was fucking easy. Art, this is what I'm here for. So you get an A. Now, to do this a little bit more, you need to know what each letter is worth. Like, what is the grade value worth? So A and A plus is worth a 4.0. An A minus is 3.7. A B plus is a 3.4. A B is a 3.0. B minus is a 2.7, and it keeps going like this. A C plus is a 2.4, and a C is a 2.0. A plus is get check. You should get like a 4 point, about the 4, I think it's 4. It might be 3, it might be 0.3. Oh, fuck, I think it is 0.3, let me look. Point value for B plus, that would, or B minus. No, B plus. 3.3, it's not 0.4, it's 0.3. And that makes the C plus 2.3. So let's go through and figure out what the stats person's GPA is, the person that liked the math and English, and let's go through and see what the other person got. So for like the blue one, they had, what I need to do is take the number of units and multiply it by the grade score. So maybe I'll write the grade score in here. This is a 4.0, 4.0, 2.0, 2.0. This is, I'm doing green over here, so let's keep the greens consistent. 2.0, 2.0, 4.0, 4.0. So if I'm going to calculate the blue score, the points they have are for stats, gives 4 times 4.0, which is 16. I specifically chose like nothing with plus or minus to keep this math easy. The English is the same. 4 times 4.0 is 16 again. The library is 1 times 2.0, which is 2. And art is 3 times 2.0, which is 6. The total there, because we got to do the summation thing. If I add those up, that is 32 plus 8 is 40. The total number of units is 12. So someone's GPA that got that AACC with the heavy ones on the math and English, 40 divided by 12 is 3.33 GPA. If we take a look at the other group, they had 4 times 2.0, which is 8. 4 times 2.0, which was 8. 1 times 4.0, which was 4. And 3 times 4.0, which was 12. The total here is 32. So if I calculate, if I do 32 divided by 12, you get 2.67. Both students got 2 A's and 2 C's. Their GPAs are drastically different. So, what does this mean for you in a normal semester? If you're like, I'm not working, I'm gonna bite off a lot, I wanna like knock out a bunch of units. Maybe I'll, like, I think they make you get a approval if you do above 19. But like, I've seen some students go like, I'm doing 20, I'm knocking out 20 units. If you do that and they have different unit values, and you find yourself like, I bit off more than I can chew, like I'm gonna do like poorly in all my classes, maybe even fail, and it's after the withdrawal date, you're like, you're gonna have to fucking worry about like, how can I salvage my GPA? Focus on passing the ones that are more units. Like say this student was doing like B's and everything, and like, I don't want a B, so he tunes out of art and liberal studies or library and study skills, and he got his score up to, a B would be a 3.0. He got his GPA up to 3.33. This student's like, I had a B, I don't want a B, I like art, fuck math and English. Now they ended up with a GPA below B. They kind of screwed themselves. A GPA of, if you got all B's, it's gonna be 3.0. You don't even need to calculate it, it just washes itself out. If you're having a hard time this semester and you can't drop a class, you gotta weigh how many units it is versus how much time it is. If it's only like dumping one tough class, like let's say you've got, higher algebra or calculus or some shit like that that you don't, like you're struggling with, or chemistry that you're struggling with, you may be able to dump one class or do poorly in one class, get a D or a C or an F if you need to, and end up still getting A's and everything else and do decent on your GPA. Or it may be like you're just falling behind, you need to like get lower on 2 scores. I think it's better off to not get any Fs. I think they start putting you on probation if that happens. You can replace D scores and Fs, they get overwritten with GPA. Did you ever find anything out? That was yesterday, right?
Yeah,
Did they get back to you?
no, I'm going after.
Okay. They're supposed to replace, like if you get a D and you take the class again, they replace your score with whatever highest score you get. It's supposed to be on your GPA and stuff like that. I don't know that it always is. But it's worth looking, he's gonna look into it. He had a question about it.
So how do I get an A and my GPA drops? I'm like, huh? No.
Right. And it was on, what was it, what's it called?
Social study.
No, not the class, the website or wherever you were looking at.
Oh, it's my giant dashboard. It's where your degree works are.
The degree works, that's what I was thinking. All right, that's it for the lesson. If you want to go, that wasn't that much long, another 10 minutes. If you want to go, you are free to get the fuck out. If you want to stay here and work, you can. If you want to ask questions, you can. I'm here till